I'm in the pink packet right now. The final exam review packet, you can just, that's your homework for the rest of the year. We're not, not really working on that. Okay, so polar axis is a circular grid. These order pairs are written, the first number is the radius. It's always radius first and angle second. On the back of those boards, samples, the back has a table. So you will have to give me a table of ordered pairs. So this is how you're gonna list your ordered pair. There's many different ways that you can do a polar. This one is actually set up to be similar to the unit circle, where it's just going 30, 45. It's just listing the angles on the unit circle. But you don't have to do that. I have to look at the axis we're giving you for the project. I believe is counting by tens. So it goes, 10, 20, 30, 40, 50, 60, 80. I think it's counting by tens. I have to look at it. But you can count your angles many different ways. So let's go ahead and label our angles going around. So if you remember, if not, you can pull out your unit circle and copy from there. Okay, so the first order point we have is at 490. So this means I'm going to find my angle of 90. And this 4 is the radius, which means it's the fourth ring from the center. So this is my radius. So 1, 2, 3, 4. So right here where you see my laser or whatever, that's where that order pair would be. This is point A. Point B, you're going to find 210. Go out to the third ring. That's point B. So this has a negative radius. So every angle, so if I find angle 120, that would be right here. Angle 120 actually is the same as angle 300. Do you see how they share? They actually kind of share a line on the unit circle. So if it's negative, that means that I'm counting backwards. So instead of going up, I'm counting back. So it actually is going to land right there. So negative means you count backwards. So that would be right here. So this is 120. If it was positive 1, I would go up 1. But because it's negative 1, I'm going backwards. 60 degrees is right here. Who does 60 share an angle with? 240. So because it's negative 3, instead of me going up, 1, 2, 3, I'm going to go back. 1, 2, 3. So it's going to actually land right there. Okay, negative 330. If you have a negative angle and you want to write it as positive, remember, going back, if you were to add 360 to it, this angle is the same as saying negative 2.5, positive 30. Okay, they're co-terminal angles going back to January. They're actually the same. So a negative 330 angle is the same as a positive 30 angle. except one rotates clockwise and the other one rotates counterclockwise. So 30 degrees would be here, but because it's negative, I'm counting back towards 210. So it's actually going to land 1, 2.5. It's going to land right in front of E. So it's going to land right in front of B, sorry. E is right in front of B. So it's going to be right here. Oops. Okay, negative 45. So negative 45 again, if you want to in your calculator, if you would rather deal with a positive angle, if you take negative 45 plus 360, then that's going to tell you that that's the same as positive 315. And again, that's just optional. You will be using an online calculator to graph your project or to help you with your project. So if this is just for reference if you were trying to do some of it by hand, but it would be 5 positive 315. Again, I'm just renaming these angles with a positive. So 5 positive 315 is the same as 5 negative 45. So positive 315 would be here. And it's a positive 5, so we're going to count out to the 5th ring. So that'll be 1, 2, 3, 4, 5. And this polar axis only goes out to 5, so it's on the edge. And then lastly, you have 180 and negative 2. So this is 180, but negative 2 means I'm counting backwards, 1, 2. So that would be right here. So that would be G. All right, any questions about how to graph so far? This is just the basics. So a polar grid is just graphing, except now it's circular. A lot of engineering majors, depending on what field of engineering, a lot of things are graphed on a polar grid. So this is just kind of a really basic, generic introduction to polar. Really basic. All right, so now let's do it again, except this time we're going to name our angles in radians. Now, when you submit your project, your angles have to be in radians, not degrees. So I'm going to go ahead and go around the unit circle, and this time I'm going to label them in radians. I'm going to do it the way I do it, which is I always do my 30s, and then I go back and do my 45. So I got 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, 7/6, 8/6, 9/6, 10/6, 11/6. Then I go back and do my 1/4. So I got 1/4, 2/4, 3/4, 4/4, 5/4, and 7/4. And of course, 0 can be the same as 2 pi. So we're going to just label them again, except now all of our angles are in radians. So we have our first one, which is 3 and 5 pi/6. So 5 pi/6 out to the 3rd ring will be 1, 2, 3. That'll be right here, and that would be H. Two pi/3 is here, except it's a negative. So 2 pi/3 is sharing with 5 pi/3. So because it's a -2, I'm going to count backwards. So it's going to count backwards, 1, 2. So it actually is going to land right here. And that would be point I. J, pi, go out to the 4th ring. K, 3 pi over 4, go backwards to the -2. L, 11 pi over 6, we're on the 3rd ring. So I, J, I, K, and L are really close together. I didn't realize how close they were. They're all like right huddled up together. And then pi over 6, you're going to count backwards. So that would be 1, 2, 3, 4. So that would be here. Because it's a negative pi, it's going towards 7 pi over 6. So that would be your M. And then the last one, -3 pi over 2. So I'm just going to show you if you get a little confused. You're adding 2 pi. If this is only if you need to. If you don't need to, you don't have to do it this way. But -3 pi over 2 is the same as pi over 2. So this angle is the same as -5 and pi over 2. So pi over 2 would be here, but because it's negative, I'm counting backwards. So 1, 2, 3, 4, 5. So that would be right there. Okay, any questions so far? So polar, instead of an X and a Y, we have, like we would on a regular coordinate plane, we would have X and Y. For a polar, we have a radius and an angle. All right, so I'm going to give you a moment to practice, and we're going to go through it together. Let's call this point point A. I want you to name this point 4 different ways. Now, I want to be clear that there are more than 4 ways to name this point. So first start off, and you can do it in degrees or radians, whichever you prefer. And then I'll ask for some volunteers to share one or two ways that you named it. I came up with 4 ways, but that's not the only 4 ways you can do it. So when I did my 4, I tried to do 2 with a positive radius, 2 with a negative radius, 2 with a positive angle, and 2 with a negative angle. Okay, so what's one way that you named that first point? So you did -4, 330. So let me look at that. So we know that positive 330 would be here. And then you went negative 1, 2, 3, 4. So yeah, that's a valid way. That would count. 1, what did you say? I'm sorry? 150. And then what was the radius that you used? Not 1. It can't be 1. 4. Okay. So 150 would be, let's see, this is 120. So yeah, this is 150. And it's on the 4th ring. So all of the radius that you use should be either 4 or -4 because it's on the 4th ring. So those 2 ways work. Any other way? Somebody different. Georgia? -4 and negative who?
30.
-30. So let's see. So -30 would be here. And then you would count up. So, yep, that would work. All right, one more way. Anybody got, okay, so we got a negative and a positive. We got a positive and a positive. We got two negatives. We're missing a positive radius and a negative angle. Anybody have a positive radius and a negative angle? Abby? 4 and negative. Oh, sorry. Let's see how that would work. I always got to write it first and then okay, so this is not doing what I wanted to do. Okay, so negative 330. Okay, where is negative 330? Negative 330 would be, well, no. Negative 330, so this would be positive 330.
I meant 210.
Oh, you meant to say negative 210?
Yeah, I just spoke.
Okay, so negative, so you're saying that this point would be negative 210. So negative 210, 180. Yep, I agree. That would be negative 210. And then a positive 4. I agree with that. And that's just 4 ways. And it's okay that you did it all in degrees. That's just 4 different ways. We could keep going, but that's 4. All right, so now I'm going to go ahead and erase this off. I'm going to let's go. I want you to do the same thing for point B. Four different ways to label point B. Okay, so what's one way you call this point B? So this one is on the second ring, so all our radius should be 2 or negative 2. You said 2 300? Yep, that would work. Any other ways? 2 negative 60. So negative 60 would be right here, yep. And then 2 negative 60 would work. Okay. Anybody use a negative angle and a negative angle and a negative radius? Anybody do it with 2 negatives? So 2 negatives would mean I would be here. What would this angle be negative? Negative 240. And then what would that be for your radius? So negative 240, and then what would that be? -2. That would work. All right, one more way. What'd you say, -2 who? 120. Let's see how that works. Okay, so first we got to find 120. So 120 would be right here, and -2. Yep, that works. Okay. So that's plotting polar points. All right, so now let's graph a few. So if it's a radius equals 2, that is a circle. So we're going to graph other circles, but this is a circle centered at the origin, which is the only one that you cannot graph on your project because that's too easy of a circle. So R equals 2 is simply just a circle on that second ring. I know that's kind of messy, but that's it. That's R equals 2. Find the second ring and draw a circle. An angle, both of these are lines. That's a line. So we need to find, now let's look at how this polar axis is set up. Notice that this one is counting by 30s. Or it's counting by 1/6 because we got 12 slices of pizza. So if I'm counting by 1/6, so this would be 1/6, 2/6, 3/6. So this here would be 2π/3 because this is 4/6. And we're going to draw our line to go all the way through. And that's why we can really name a line two different ways. This could also be, what else could it be? 6, 7, 8, 9, 10. This could also be 5π/6. It's the same line. All right, -7/6. So I'm counting backwards. 1/6, 2, 3, 4, 5, 6, 7. So this would be 7, -7π/6 right here. Okay. So now we have to name these, and this is where we're going to end. We're going to do these 4 and end here. Well, we got to name these 4. So the easiest to do are the circles. So this would be R equals what? Let's do these 2 first. What would that first one be? R equals what? What ring are we on? 4. And for the smaller one, we're on the second ring. Now, as far as your angles or a line, this is an angle. So this is going to be theta equals. Instead of R equals, it's theta equals. There's a lot of different ways we can name this. So I'm going to challenge you to do it in radians. So I know degrees is more comfortable, but your project has to be done in radians. So we're counting by 6s. So if I go this direction is positive. So this is 1/6, 2/6. But 2/6 reduces to what? 1/3 π/3. You could also go negative. So this would be -1/6, -2/6, -3/6. This is -4/6. -4/6 reduces to what? -2π/3. And that's just 2 ways. We could keep going, but that's enough. All right, let's go ahead and do D. And then we'll end there. Tomorrow we'll start going through the different types of graphs that you can use on your project. So this is theta equals, I want 1 positive and 1 negative, both in radians. So So I'm counting positive. This would be 1, 2, 3, 4. 4/6 reduces to what? 2/3. And then I can either count, and I could have kept going. I could have said, I could have hit this part positive and said 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That would have been 10 over 6, which is the same as 10 over 6 reduces to 5 over 3. But I want to do a negative, so let's go backwards. So let's go 1 over 6, 2 over 6. 2 over 6 reduces to, and this is negative, so let me do that again. Negative 1 over 6, negative 2 over 6. So that would be a negative pi over 3. All right, so we're going to end there, and tomorrow we will continue. I'm going to pull up the calendar here. Let me look at it.